right, let's go. Ashari told me not to do this, that she didn't care, so that's it. That's it. All right, let me quit playing. So here we go. What I'm gonna do is go through each one of the tests or quizzes that I gave you. Just go through what it entailed and maybe what lessons you could look at or whatever, and then we'll go from there. So let's just work through it. All right, Pascal's triangle. Remember Pascal's triangle? 1, 1, 1, 1, 2, 1, 1, and you use the row above to get the current row. So 2 plus 1 is 3, 2 plus 1 is 3, and into 1. So then for the next row, I've got 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 3, or 4, excuse me. And then just for the heck of it, I can keep going. So I got 1 and 1. I've got 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 and 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. And 5 plus 1 is 6. And then last but not least, 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. That's Pascal's triangle. I could keep going. Remember what we use this for, because we're about to use it on this second problem. Okay, so now find the coefficient of x squared of 1 plus 2x to the quantity to the fifth power. So remember what we do. When we're looking for the coefficients, we use Pascal's triangle. So because we're doing with the fifth power, we're looking at the fifth row. We're looking at this row. So I know I got 1, 5, 10, 10, 5, and 1. So that's initial. But because I've got, I've got this 2 in here, that's going to change some things. So watch what happens. So my first term is going to be the first term to the fifth power times the second term to the 0 power. And then my next one is going to be the first term to the fourth power times the second term to the first power. Notice what's happening here with the exponents. Then I'm going to have the first term to the third power times the second term to the second power. Then I'm going to have, for this one, so you know what, let's space these numbers out just a little bit. So 1, 5, 10, 10, 5, 1. So this next one is going to be 1 to the second power times 2x to the third power. Then this one is going to be 1 to the first power times 2x to the fourth power. And need to space some more. Oops. I'm going to make me look bad. There we go. All right. So now I've got 1. So that's going to be 1 to the 0 power times 2x to the fifth power. Okay. Now, first off, I want you to notice that once I got past the first power, I started putting parentheses around this because I got to remember that whatever power's here, it happens to both my terms, the 2 and the x. Okay, so that's the first thing. Second thing, as I went through my term, I've got 1, the second term, the third term, fourth term, fifth term, sixth term. If I look at my exponents, they add together to become 5. 5 plus 0, 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, and 0 plus 5. So now I'm going to figure out what term I get here because I'm looking for the coefficient of x squared. So when I multiply these two things, that's 1 to the fifth power, which is 1, and then 2x to the 0 power. I actually need to put this whole thing. 2x to the 0 power is 1. Anything to the 0 power is 1. So that's 1 plus. Next, I've got 1 to the fourth power. You know what? Let's not do that. Let's do this instead. We're going to start with the initial coefficient that we get from Pascal's triangle. So it's 5 times 1 to the fourth power is 1 times 2 x to the first power. So when I multiply that all out, I'm going to have 10x. All right, Malcolm, do I need to rewrite this? All right, you boss. So let's try that again. So this first one is going to be 1 times 1 times 1 plus, this one's going to be 5 times 1 times 2x. Well, that's just 1. This is 5 times 2 times 1, so that's 10x. The x just comes along for the ride. So right here, I'm going to have 10 times 1, because 1 to the third power is 1, times 2x to the second power. 2x to the second power is 4x squared, because the 2 gets taken to the second power and the x. That's why I put these parentheses around there, okay? So when I multiply this all out, I got 10 times, that's a 10. 10 times 1 times 4, so that's 40x to the second power. I can stop right there because that's what we asked for. Find the coefficient of x squared. Well, the coefficient of x squared is 40. But I'm going to continue this just so you can recognize what we need to do next. So I'm going to take the term up top, 10, and then 1 to the second power, that's 1, and then 2x to the third power. 2 to the third power is 8, x to the third power is x to the third power. So that's 8x to the third. So now my next term is 10 times 1 times 8, so that's 80x to the third. Right here, I've got 5 times 1 times 2 to the fourth power times x to the fourth power. 2 to the fourth power is 16. And then x to the fourth power is x to the fourth power. So when I multiply those all out, I get 5 times 1 times 16. Guess what that is? It's 80. So that's 80x to the fourth. And then finally, I've got 1 times 1 to the 0 power, which is 1, times 2x all to the fifth power. Well, 2 to the fifth power is 32. And then x to the fifth power is that. So then finally, oops, I need to move that up. 1 times 1 times 32x to the fifth. So then that's going to be 1 times 1 times 32. So that's 32x to the fifth. Now those is a little scrunched. So I'm going to trace this over in red so you can see it. So I have 1 plus 10x plus 40x squared plus 80x to the third plus 80x to the fourth plus 32x to the fifth. So I've got all of those terms. It's only asking me for x to the second power. So the x to the second power, the coefficient, the constant is, excuse me, 40. So that's where I got that from. All right. So next. Calculate the following factorial. I've got 10 factorial divided by 7 factorial. Remember what a factorial means. 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 is 3 times 2 times 1. That's 10 factorial. 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. So with this, I can say 10 times 9 times 8 times 7 factorial. And I got 7 factorial, so see what happens? These two things cancel each other out. And now I'm left with 10 times 9 times 8 over 1, or just, anything over 1 is just itself. So that's 720. 7 times 8 is 72. Well, 9 times 8, excuse me, is 72. Times 10 is 720. So bada boom, bada bing, bada boom. Bada bing, bada bing, bada boom, bam. Okay, so now I'm going to look at this. Definitely going to use 2 different colors for this. So I'm going to start with this one. What we were doing back then was using I. Remember what I equals. I equals the square root of -1. So I squared equals -1. So watch what we do here. See, I've got this, and Before, I couldn't find any solutions for it. But then when we got I could. Because what ends up happening is x squared minus 16 can be factored. It can be factored to x plus 4 times x minus 4. What is this called, Malcolm? What do we call it? Yep, the difference of squares, right? Because that's a square and that's a perfect square and that's a perfect square. So, and I'm subtracting them, so that's the difference of squares. But see, here's the problem. That works when you have a difference. That means you're subtracting. But what do you do when you're adding? You're kind of messed up. Except now we got I. So I changes everything. So what I'm going to do is I'm going to change this problem to x. Well, you know what? I'll rewrite it. X squared plus 16. I'm going to make that x squared minus a negative 16. So now it is trying to be the difference of squares, but see, negative 16 isn't a square. It isn't a perfect square. But there is something we can do to make it so. If I say x minus 4 times x plus 4, and then I put in this little I right here and this little I right there, guess what happens? That I gives me, when I multiply this all out, I'm going to have x squared. The middle terms are going to cancel off because I got negative 4i and positive 4i. And then the final terms are going to be negative 4i times positive 4i. Well, the negative is going to make it negative. I've got 4 times 4, so that's 16. And then I've got I times I, that's I squared. Well, what did I squared equal? It equals negative 1. So then that's going to be plus 16. So that's how I find this. That is my answer right here. Right? This is extra. You don't need to do that, but I wanted you to see why it works. Okay? That I can get 4i or negative 4i times positive 4i, and that gives me negative 16 when I multiply them. And so what are the solutions? What are the actual solutions? The actual answer is x can equal 4i or negative 4i. So that's my total answer. I'd want to see this work though. All right, so now we're going to do the similar thing over here. Let's go. I don't want to make it too bright. Let's go with the light blue. Okay, so I look at this. Well, initially, I've got x to the fourth and I've got 9. So I think, what two things do I multiply to get x to the fourth? Well, x squared, of course. What two things do I multiply to get 9? 3 and 3. Nope, that doesn't work. Why doesn't it work? Because my middle term needs to be 3 plus 3, and that ain't 3 plus 3. So let's go back. So what two things do I multiply to get 9? 1 and 9. 1 times 9 is 9, but 1 plus 9 is 10. And the plus, both signs are plus, so this is plus. Now see, if you look, I'm going to draw this and erase it, so just bear with me. X squared minus 1 and x squared minus 9 is what? Both of those qualify to be called what? Come on, Malcolm. It is the difference of squares. Remember, difference means subtraction, and we're talking about perfect squares. 1 is a perfect square, 9 is a perfect square, and of course, x squared is a perfect square. So that's the difference of squares. So that's what I want you to put in your head. Now, that being said, so let's finish this. If I think about this like x squared minus a negative 1 times x squared minus a negative 9. So now over here, I've got x plus, now this is going to be 1 times I. So I'm just going to put I, because 1 times I and I means the same thing. Then I'm going to have x minus I. That's the difference of squares. X times x gives me x squared. Positive I and negative I give me a negative 1. And because that's a negative, I'm sorry, it gives me a negative I squared. The I squared is a -1, so the negatives cancel off and I get a +1 right here. So that's what I'm doing. So over here, I do the same thing. I've got x, and how do I get 9? 3 times 3. But how do I get -9? Well, that's -3i times x plus 3i. When I multiply those two, I get x squared plus 9. When I multiply those two, I get x squared plus 1. Okay? So then what's my final answer? My x equals I, -I, -3i, and +3i. That's my answers. So that's how you do this. All right? That is how you do this. Now this, I believe, was module 3. So next, I want to go back to that. All right, so module 3. So see, binomial theorem was talking about the the Pascal's triangle and multiplying, to get what coefficient. That's what that was talking about. Okay, and then I believe factorials were. Shucks, I don't remember where factorials were. It was somewhere in here. I have to double check, so I'll go back and look at that. But that's where we're going back. We're starting at module 3. And then we got I for those solutions. So let's see what we got here. Rational functions, nope. I believe that's right here. So I'll double check those. I probably should have not put this in the video because I wasn't sure. So I'm going to stop right there for this first one. And then we're going to look at the next ones.